When wires pull straight through a junction box without any splices, each conductor still counts towards the total box fill calculation. According to the National Electrical Code, each pull-through wire is considered equivalent to 2.25 cubic inches for number 12 American wire gauge conductors. It is important to note that the number of pull-through wires does not alter the individual cubic inch requirement per conductor. In your example, if you have 6 number 12 American wire gauge wires pulling straight through a junction box, each wire contributes 2.25 cubic inches to the total fill. Therefore, the total cubic inch requirement for those 6 wires would be 6 multiplied by 2.25, which equals 13.50 cubic inches. The purpose of this calculation is to ensure that the junction box is adequately sized to accommodate the conductors without overcrowding, which can lead to overheating and potential safety hazards. It is essential to use the correct cubic inch values for the wire gauge being used. The NEC provides tables that list the cubic inch volume required per conductor based on wire size. For example, number 14 American wire gauge conductors require 2 cubic inches each. Number 12 American wire gauge requires 2.25 cubic inches. Number 10 American wire gauge requires 2.5 cubic inches. Number 8 American wire gauge requires 3 cubic inches. And number 6 American wire gauge requires 5 cubic inches. These values are for individual conductors that either terminate or pass through the box. When conductors pass through without being spliced or terminated, each conductor is counted only once for box fill calculation purposes. The primary reason for calculating box fill is safety. Overfilled junction boxes can lead to several problems. Firstly, excessive heat can build up within the box, potentially damaging the insulation of the wires. This can cause short circuits, ground faults, and even electrical fires. Secondly, overcrowding can make it difficult to safely work inside the box, increasing the risk of accidental contact with live wires during maintenance or future modifications. Thirdly, an overfilled box can put undue stress on the wire connections, potentially causing them to loosen over time, which can lead to intermittent electrical problems or complete circuit failure. Furthermore, it is important to differentiate between conductor fill and conduit fill. Conductor fill refers to the number and size of wires allowed in a conduit, while box fill refers to the amount of space occupied by conductors, devices, and fittings within a junction box. Both are critical for ensuring electrical safety and compliance with the NEC. The NEC provides specific guidelines for conduit fill based on the type and size of the conduit, as well as the type and size of the conductors. The allowable percentage of conduit fill varies depending on the number of conductors being installed. For example, when there are 2 or fewer conductors, the allowable fill is 40%. When there are more than 2 conductors, the allowable fill is 40%. These limitations are in place to ensure that there is adequate space for heat dissipation and to prevent damage to the conductors during installation and operation. Always consult the NEC tables for the specific requirements based on your particular installation. In addition to calculating the volume occupied by conductors, it is also necessary to account for the space occupied by devices such as switches, receptacles, and equipment grounding conductors. Each device typically counts as 2 conductor equivalents based on the size of the conductors connected to it. For example, a switch connected to number 12 American wire gauge conductors would count as 4.5 cubic inches toward the total box fill. Equipment grounding conductors also need to be accounted for, but the rules can be slightly different depending on the number and size of the grounding conductors. Typically, all equipment grounding conductors entering the box are considered as 1 conductor based on the largest equipment grounding conductor present. For instance, if you have 3 equipment grounding conductors size number 14 American wire gauge, number 12 American wire gauge, and number 10 American wire gauge, they would be counted as 1 number 10 American wire gauge conductor, which requires 2.5 cubic inches of box fill. When selecting a junction box, always choose one that is appropriately sized for the number and size of conductors, devices, and fittings that will be installed inside it. Using a box that is too small can lead to code violations, safety hazards, and future problems. It is also important to consider the material of the junction box. Metal boxes are typically more durable and can provide better protection against physical damage, while non-metallic boxes are corrosion-resistant and suitable for damp or wet locations. The choice of box material should be based on the specific environmental conditions of the installation. In summary, when dealing with pull-through wires in a junction box, each wire contributes to the total box fill calculation based on its gauge size. For number 12 American wire gauge conductors, each pull-through wire counts as 2.25 cubic inches. Proper calculation of box fill is essential for ensuring electrical safety and compliance with the NEC. Always use appropriately sized junction boxes and consider the space occupied by conductors, devices, and equipment grounding conductors. Remember to consult the NEC tables for specific requirements related to conductor fill, conduit fill, and box fill calculations. Ignoring these requirements can lead to serious consequences, including electrical fires, equipment damage, and potential injury. Additionally, it's crucial to understand that using pull-through conductors should not be a substitute for using a properly sized junction box. The intention of pull-throughs is for situations where the wiring is simply passing through the box to continue to another location, not as a workaround for an undersized box. If you find that you have too many splices or connections to fit comfortably and safely within a junction box, the correct solution is to install a larger box. This ensures that all connections can be made securely and that the wires are not overcrowded, which could lead to overheating and potential hazards. When calculating box fill, always start by identifying the number and size of all conductors entering the box. This includes all hot wires, neutral wires, and equipment grounding conductors. Next, determine the cubic inch volume required for each conductor based on its size using the NEC tables. Add up the cubic inch volumes for all conductors to get the total conductor fill. Then account for the space occupied by any devices, such as switches and receptacles, by adding the appropriate volume for each device. Finally, compare the total calculated volume to the cubic inch capacity of the junction box to ensure that the box is adequately sized. If the calculated volume exceeds the box capacity, you will need to select a larger box. The NEC also provides guidelines for the installation of junction boxes, including requirements for accessibility, support, and protection. Junction boxes must be readily accessible for inspection, maintenance, and future modifications. They should be securely supported to prevent them from falling or shifting, and they should be protected from physical damage and environmental hazards. In damp or wet locations, use weatherproof junction boxes and fittings to prevent moisture from entering the box and causing corrosion or electrical problems. Regularly inspect junction boxes for signs of damage, corrosion, or overheating. If you notice any problems, such as loose connections, damaged wires, or discoloration of the box, take immediate action to correct the issue. Ignoring these problems can lead to more serious and costly repairs down the road. Always turn off the power to the circuit before working on any electrical components, including junction boxes. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical shock and other hazards. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electricity can be dangerous if not handled properly, and it is always best to err on the side of caution. Remember that electrical codes and regulations can vary depending on your location. Always check with your local authorities to ensure that you are following the correct requirements for your area. The NEC is a comprehensive set of guidelines for electrical installations, but it is not a substitute for professional training and experience. If you are unsure about any aspect of electrical work, seek guidance from a qualified electrician or electrical inspector.